Suppose the spheres A and B in previous exercise have identical sizes. A third sphere of the same size but uncharged is brought in contact with the first and then brought in contact with the second and finally removed from both. What is the new force of repulsion between A and B? So let us consider two spheres A and B, which are having initial charge QA and QB, and their centers are separated by a distance as 50 centimeter. Shall write R is equal to 50 centimeter, that equal to 0.5 meter. Now QA and QB are both being equal, that is 6.5 into 10 to the power minus 7 coulomb. We'll take these values from the previous exercise. And now a third sphere of identical size, and you can say if which is initially uncharged. So I'll take QC, that is the initial charge on sphere C, which is 0 here. Now we will make contact of C with A. So now C is brought to contact with A. We will consider QC dash is the final charge on C after making in contact with A, and that is equal to QA dash, that is final charge on A after making in contact with C, and they will be equal because they have identical sizes. So that will be equal to their initial charges, that is QA plus QC by 2. So QA is here 6.5 into 10 to the power minus 7 plus 0, as you can see initial charge on C is 0 divided by 2. So this will be 3.25 into 10 to the power minus 7 coulomb. Now this sphere C is removed from A and now it is kept in contact with B. Now C is brought in contact with B. So the final charges on B and C will be equal as they have identical sizes. So QB dash with a final charge on B and QC double dash with a final charge on C after removing or after contact with B. So we can write QB dash is equal to QC double dash, which is the average of their initial charges, that is equal to QB plus QC dash by 2. So QB, as you know, that is 6.5 into 10 to the power minus 7 plus QC dash is here 3.25 into 10 to the power minus 7 divided by 2. On simplification, this will be 4.875 into 10 to the power minus 7 coulomb. So this will be the final charge on C and this will be the final charge on B. Now C is removed from B. Now we can find the new charges on A and B after removing C. Now the new force between A and B will be K, QA dash and QB dash divided by the R square, that is 0.5 square. So on substituting the values here, we will get 9 into 10 to the power 9. QA dash already you have found here, that is equal to 3.25 into 10 to the power minus 7, and QB dash that is 4.875 into 10 to the power minus 7 divided by 0.5 square. So this will give you a value 5.7 into 10 to the power minus 3 Newton. This will be the final force between A and B.